In this video, we are going to do these three questions from the chapter Heron's formula. Let's begin with the first question. Now, if I see in the first question, we have to show that the area of an equilateral triangle is root 3 over 4x square, where x is the side. Well, we already know that this is the formula we apply for finding the area of an equilateral triangle, but this time we have to show that. So we are going to take an equilateral. Let's say I took one equilateral triangle, and we are going to take each side as x as per the question, and then we'll be applying Heron's formula to show that area of this equilateral triangle. Now, first thing that we do is to find S, and what is S? That is semi-perimeter, which is sum of all three sides divided by 2. That results to give you S as what? 3x over 2. Then we'll apply this Heron's formula for calculating the area, and it should come as what? This is S, my S, first of all, it is S, then S minus A. This is S minus A, and A is X. Then we have again S minus B, and B is X. A, B, C are the sides. Well, in our case, A, B, C are X only, minus X. Now, for further calculation, what we can do is to simplify this. Now, what is this? This is on simplifying 3x minus 2x, that is x over 3, x over 2, sorry. And this also 3x minus 2x over 2, that is x over 2, and finally x over 2. Now check, if we continue solving over here, we can see that if I rewrite this question, this 3 into x by 2, I'll write this as 3 into x by 2. Now check here, there is a doublet of this and a doublet of this. So we can take it outside. So we can write x over 2 as it has doublet and x over 2. Now, one more time, I mean to say that over here, we have a doublet of x over 2 and another doublet of x over 2. So we can write outside it. And what we are left inside, we are left inside only root 3. Now check what we got here. As, if I write root 3 first, and this is what? X square by 4. So 4 I can write below, and then it is x square. This is what we need to verify in the first part. Now I'll come to the next question. In the second question, it says one side of a right angle triangle is 20 centimeter and the difference of the length of its hypotenuse and other side is 8 centimeter. Now what we have to find out is the sides and the area of this triangle. So we need to make a right angle triangle first. Let's say I make a right angle triangle and I'll name this as, say, ABC. So first thing, what we know, that one side of this triangle is given as 20 centimeters. So I can take any of its sides. Say I took this as 20 centimeter. And we are given the difference of the length of hypotenuse and the other side. So it implies that you should know that hypotenuse is the longest side and it is the side opposite to 90 degree. Now, so if I take hypotenuse as x, this has to be x minus 8. As you know, there is a difference of 8. Alternately, if you take this as x, then it should be x plus 8. One more time, as I said, hypotenuse is the longest side, and that's why the hypotenuse, as you can see, I've taken 8 more than x. There is a difference. Now, if you can apply a Pythagoras relation between them, and this is what? The square of the hypotenuse is equal to sum of the squares of the other two sides. So hypotenuse is what here? It is AC. So we can say that square of the hypotenuse is equal to the sum of the squares of other two sides, that is BC whole square. AC is x here, so it is x square. AB, I can see it's 20, so it's 20 square, and BC is x minus 8, so it's x minus 8 whole square. 20 square is 400. If I apply a minus b whole square over here, so this is a square minus 2 times a into b will give you minus 16x, plus 8 square is what? 64. Now check here, x square and x square get cancelled. If I transpose, minus 16 to the left hand side is going to be positive 16, and this will give you results to give you 464. So now we get x, and this is how much? 464 divided by 16. Now you can figure out that they can be reduced: 4 4 times, and 4 1 times, 4 1 times, and 4 6 times. Check, this is again divisible by 4, 4 2 times 8, and we are left with 3 as the remainder, so that is 36. So 4 9 times. So this is how we got the value of x. So once we got the value of x, and what is x over here? It is one of its sides. So we have to find the other side, and we got the hypotenuse. Let's say hypotenuse over here is what? 29, and this is going to be 8 less than this, which is 21. 29 minus 21. Now I can see that we have one more part, is to find the area of this triangle, and area of this triangle is what? We are going to apply half base into height to get the area. So we'll say that area over here is half multiplied by the base. Base, needless to say, it's 21 as the base, and altitude is 20. This can be reduced by 10 times. So we get 21 into 10, that is 210 centimeter square. That should be the area of this right angle triangle. Now we're on the last question. It says find the area of an isosceles triangle whose non-equal sides are 12 centimeter and having the corresponding altitude as 7.5. That's an easy question, but student generally have confusion over here. Now check over here. If I name this triangle as ABC as an isosceles where AB and AC are the equal sides, so non-equal sides by default has to be what? As the BC only. This is the non-equal sides, right? So, and then the altitude or corresponding altitude has to be this only. This is the altitude. So in fact, we know the base and the altitude, right? So we can say the base over here is how much? It's given as 12 centimeter. If you read the question, you'll find it again. And this is the altitude, and altitude is h, which is 7.5. So there is nothing on this question. It's just that we have to apply area of a triangle as half base into height, and half multiplied by the base as 12 and height, which is altitude, as 7.5. I can see this can be reduced. So now we'll get the area by multiplying 6 with 7.5. So 7.5 into 6 is 45. So we'll say that the area is how much? 45 centimeters square. This is how we got the answer for this question.